What if I told you that the most common stars in the universe are also the most mysterious? Imagine a star so small and faint that it's almost invisible, quietly burning for trillions of years, only to disappear without anyone noticing. These are the red dwarf stars, silent giants that make up the bulk of our galaxy. But why do they fade away so quietly? And what does their silent end mean for the future of the cosmos? In this video, we're diving into the secrets of red dwarf stars, exploring their life cycle, and uncovering the mysteries behind their unseen deaths. Stick around, because what you're about to learn could change the way you think about the universe forever. Don't forget to subscribe to Small World, and let's embark on this astronomical adventure. Red dwarf stars, the quiet giants of the cosmos, are not as flashy as their larger counterparts, but they are just as fascinating. These stars are small, often less than half the mass of our sun, and their cool temperatures give them a faint glow that barely illuminates the surrounding space. Despite their subtle presence, red dwarfs are the most common type of star in the Milky Way, quietly outnumbering the more brilliant stars we often hear about. Imagine looking up at the night sky and knowing that most of the stars you see aren't even red dwarfs. They're just too faint to be visible to the naked eye. These stars are the silent workhorses of the galaxy, quietly burning away for billions, even trillions of years, without ever making a scene. The life cycle of a red dwarf is a slow and steady process, much like a marathon runner pacing themselves for the long haul. Born from collapsing clouds of gas and dust, these stars ignite their nuclear furnaces at a leisurely pace, burning through their hydrogen fuel at a fraction of the rate of larger stars. This slow burn is what grants them their incredible lifespans, allowing them to shine for an astonishing length of time. To put it in perspective, while a massive star might burn brightly for a few million years before going out in a blaze of glory, a red dwarf could keep glowing for trillions of years, long after most other stars have died. It's as if these stars have cracked the code to cosmic longevity, content to live quiet, uneventful lives. One of the most intriguing aspects of red dwarf stars is their stability. Unlike larger stars, which eventually exhaust their fuel and explode in a supernova, red dwarfs are far less dramatic. They burn their fuel so efficiently that they never reach the point of catastrophic explosion. Instead, they quietly persist, slowly fizzling out over eons. This stability makes them potential hosts for habitable planets. Picture a planet orbiting one of these steady stars, basking in a consistent, if dim, light for billions of years. The idea that life could evolve and thrive on such a planet isn't just science fiction. It's a possibility that astronomers are keen to explore. The very characteristics that make red dwarfs unremarkable in the night sky could make them ideal for sustaining life over the long term. Yet, despite their abundance and stability, red dwarfs hold mysteries that continue to puzzle scientists. Their faint glow and slow evolution mean that much about them remains unseen, hidden in the shadows of their more prominent stellar siblings. For instance, the final moments of a red dwarf's life are shrouded in mystery. Unlike the explosive deaths of larger stars, red dwarfs fade away so quietly that it's almost as if they vanish without a trace. This unseen star death is one of the many dwarf star mysteries that keep astronomers searching for answers. But what exactly happens when these stars reach the end of their incredibly long lives? How do they transition from being one of the most stable objects in the universe to a quiet supernova that no one witnesses? These questions lead us to explore the silent fade of red dwarfs and the invisible star collapse that follows. As red dwarf stars reach the twilight of their existence, they don't go out with a bang like their more massive counterparts. Instead, their end is marked by what can only be described as a silent fade. Imagine a candle that burns so slowly and steadily that, when it finally runs out of wax, there's no dramatic flicker, just a quiet, almost imperceptible dimming until it's gone. That's the essence of a red dwarf's death. These stars burn through their hydrogen fuel at such a leisurely pace that, when the fuel is finally depleted, they simply cool down and fade away. There's no supernova, no explosive finale, just a gradual decline into darkness, like a light bulb dimming until it's completely off. The reason we can't see the death of a red dwarf is tied to this very process. Unlike larger stars, whose deaths are visible across the cosmos, red dwarfs slip away quietly, their demise unnoticed. It's a bit like watching a distant fire burn out from miles away. If you weren't paying close attention, you'd miss the moment it finally goes out. This quiet supernova, if it can even be called that, is so faint that it's virtually invisible to our telescopes. It's a stark contrast to the violent deaths of massive stars, whose supernovae light up the sky and leave behind spectacular remnants. Red dwarfs, on the other hand, leave behind no such grand displays, making their deaths one of the more mysterious events in the universe. As these stars approach their final moments, they undergo a transformation that's just as unassuming as their lives. When a red dwarf exhausts its hydrogen, it begins to cool and contract, slowly dimming until it becomes what astronomers call a white dwarf, a small, dense remnant that continues to cool over billions of years. This cooling process is so gradual that it could take longer than the current age of the universe for a white dwarf to completely fade into obscurity. This means that no red dwarf has yet died of old age. The universe simply hasn't been around long enough for us to witness this final stage. It's a sobering thought, reminding us of the vast timescales at play in the cosmos. The silent fade of red dwarfs poses intriguing questions about the fate of the universe itself. If these stars, the most numerous in the galaxy, can vanish so quietly, what does that mean for the future of the cosmos? As red dwarfs continue to fade away, they take with them a piece of the universe's light, leaving behind a darker, quieter cosmos. This unseen star death is not just a scientific curiosity, it's a glimpse into the ultimate destiny of the universe, a place where light becomes increasingly rare and darkness slowly takes over. But what does this mean for the long-term evolution of the universe? To answer that, we need to look at the impact these fading stars will have on the cosmic landscape and the role they might play in the distant future. The impact of red dwarf deaths on the universe is subtle yet profound. These stars, with their incredibly long lifespans, are set to outlive nearly every other type of star. Imagine a universe billions of years from now, where most stars have already burned out or exploded in brilliant supernovae. In this future, red dwarfs will still be quietly shining, outlasting their more flamboyant siblings. Their longevity ensures that they will be among the last stars to provide light in a universe that is slowly growing darker. As other stars fade into history, red dwarfs will continue their slow burn, keeping the cosmos illuminated for trillions of years to come. But as red dwarfs eventually reach the end of their life cycles, the universe will face a future where even these hardy stars begin to disappear. The quiet supernova-like deaths of red dwarfs will gradually reduce the number of light sources in the cosmos, leading to a universe where darkness prevails. This slow dimming of the cosmos is not just a theoretical scenario. It's the inevitable consequence of stellar evolution. The fading of red dwarf stars marks the universe's gradual transition into an era dominated by cold, lifeless remnants, white dwarfs, black holes, and the ever-present dark matter. The once vibrant cosmos, filled with light and life, will give way to a quieter, darker reality. Yet, there's a silver lining to this cosmic fade-out. Even as red dwarfs cool and dim, they may continue to host habitable planets for an incredibly long time. Picture a distant world orbiting a red dwarf, where life has evolved to thrive in the dim light. As the star slowly fades, life on these planets might adapt to the changing conditions, potentially surviving for trillions of years. This possibility raises fascinating questions about the resilience of life and the kinds of environments where it might be found. In a universe where most stars have died out, planets around red dwarfs could be among the last bastions of life, holding on to existence in an otherwise desolate cosmos. The potential for habitability around fading red dwarfs also has implications for future exploration. As we search for life beyond Earth, these long-lived stars might be prime targets. The stability and longevity of red dwarfs make them ideal candidates for supporting life over vast timescales. Imagine future space missions focusing on these stars, seeking out the last outposts of life in the universe. This search could redefine our understanding of where and how life can survive, even as the universe itself winds down. But what does this all mean for our understanding of the cosmos? As we continue to explore the mysteries of red dwarf stars and their quiet demise, we gain insights into the ultimate fate of the universe itself, leading us to question what lies beyond the dark horizon of cosmic evolution. So, now that you've uncovered the secrets of red dwarf stars, what does it mean for you? Could their silent fade be a reflection of the quiet, unnoticed moments in our own lives that hold immense power? Just as these stars continue to shine long after others have burned out, perhaps there's a lesson in resilience here. A reminder that sometimes the quietest forces have the most lasting impact. But how will you apply this knowledge? Will you seek out the subtle but powerful influences in your own life? I encourage you to take a moment to reflect on the invisible forces shaping your path. If you found this exploration of red dwarf stars fascinating, don't forget to like this video, share it with friends who love cosmic mysteries, and subscribe to our channel to stay updated on all things space and beyond. Make sure to turn on notifications so you never miss out on our deep dives into the universe. And before you go, if you're curious about the wild storms on Neptune and the truth behind them, check out our previous video, The Truth About Neptune's Storms Finally Uncovered. It's a journey you won't want to miss.